Right, so let's talk about application state. Right, so we've been discussing about state management, but within the context of components, right? Small components that are maintaining their state variables, whether they're integers or arrays or objects, but all within a self-contained context, right, of a component. Now we could also have the state be shared across several components, right? Where maybe you could have a one component that shares objects or arrays or complex data types with other child components, and then those child components can then share their state with other components and whatnot, right? But that introduces a complexity of communication between components, having to notify their parent components to update the state. That complexity is very brittle, right? It's very error prone, and it makes it very very hard to work with complex data structures. Right? So instead, we're going to look for another way to work with that, right? And so we're going to introduce, right, a mechanism called Redux. Right, this is a library that is specifically designed for this purpose of dealing with state, right, that doesn't belong to any one component, but it belongs to multiple components, right? That it doesn't live in any one particular state variable, within the confinements of any one component. Instead, it's its own thing, right? And then, so we need a way to um, to maintain the state, to update the state, to read the state, right? To do all the operations back and forth. We need to be able to define functions that manipulate the state, right? That add, remove, do all the CRUD operations, creating data, reading the data, updating the data, deleting the data, right? And all outside of any one component. But then components need to be able to read from this ethereal state, right, and be able to write to it, right? So Redux is a library that tries to solve this problem, right? There's quite a bit um, of libraries out there that try to solve the same issue, and Redux is just one of those. Now, Redux happens to be fairly popular in in React. Now, it's not a library that is specific to React, right? It can be used with many other user interface libraries such as Angular or Vue.js, right? Um, and it can even be used in a non-user interface, right? That want to maintain state, right? But it has a nice API that integrates very well with the React library, right? And so we're going to be using it. There's quite a few other options, right? But this is a very popular library. Now the learning curve is you know it's slightly steep, at the very beginning, in particular, mostly just for doing all the plumbing, and just hooking everything together. But once it's set up, right? Once you set up all the plumbing and everything is connected, right? It's fairly easy to use, right? Once we understand where we are in the map, in the Redux map, right? So yeah, so what we're trying to do is that instead of having the data being maintained by any one, instead of the state living any one component, we're going to rip it out. We're going to put it outside, right? And then we need a mechanism to be able to talk to it, right? And from a whole bunch of components. Yes, right. So usually the state would live in a component, in some component. You have some state, well, you have some integers, booleans, objects, arrays, state variables here, and then we want to put it in an outside, right? So what's going to happen is that we're going to put that state, right, in a store, right? A store, it's a Redux, in Redux jargon, it's where you put all the state variables, right, in that one place, right? And then you have what are called reducers that are responsible for maintaining, right, the state in the store, right? It can create new state, right? It can read the state and make it available, right? And then the store is made available inside of some top level component, right? That is the one who is holding a reference to the store, and then making it available to all the child components. So some root component you have to choose, which level is your where you want to start sharing, and then from there, right, the state is made available to any component under that umbrella or under that root component that it owns, right? Now, without passing through the attributes, right? We want to avoid that. We know we could do that, right? If you're using just what we know already, right, of the use state and passing things through attributes, but that would be a nightmare to maintain. So instead, here we have the root component where everything starts. It creates an instance of a provider, and the provider provides reference to the store, right, to where the state is, to any child components within the context of the root component, right? And these could be, they could be as nested as they want, right? There's no dependency between the two. There's no need to pass anything between. They can select, right? Child components can use a use selector, right, to read whatever the state is in there, and they can grab any data they want from there without having any dependencies between child components. And they can also dispatch events, right, clicks and drags and whatnot, and they can notify, right, the reducers to modify the state, right, so that any one component can generate a state change, and then any other component can then read from that state, right, and update. Yes. Okay. Now, why reducers? Why are these called reducers in the Redux jargon? So reducers come from a feature in JavaScript, comes from the reduce function, right, in JavaScript, which is it's a function that applies on arrays, very much like map, filter, right, find, right. They iterate over an array and they reduce that array, that data structure, right, into some other representation, which in here happens to be an accumulation, right, of the values, in the original array, accumulated into a single representation, right, of that array. In our case here, which is reducing the arrays of the elements of the array, we're accumulating with an initial value of 0, where we accumulate the values of the accumulator plus the current value. Right? So each value gets passed in, right? 1 plus 2 plus 3 plus 4, right? And you end up with 10, right? So it's converting all the items, accumulating in, using whatever algorithm you want. You can provide the algorithm however you want to accumulate it. You can accumulate it, to compute an exponent, or factorial, or exponential, or whatever you decide. It could be an object, right? And you accumulate it in any way. So that's where the name comes from, reducing some event, some collection of data structures into an equivalent representation. Okay. So that's where we're going to be writing a whole bunch of reducers. In our case, the reducer here is the function that is converting and accumulating all the values in the data structure into a single value, right? So we're going to write reducers that have an initial value. Here, the initial value is 0. So the reducers are going to have some initial value, and depending on different events, right, they will reduce that initial value into an equivalent representation, okay, which will then be the next state is going to be computed as the result of reducing the previous state into the next state. Okay. All right. So let's take another. We're coming up with a lot of jargon here. Now, because we're dealing with state variables that are non-trivial, right? Up to this point, we've seen trivial examples of state management where the state lives within a component, right? And we might have an object, an array, maybe an array of objects, something complex, but it's within the context of one component. Yes. Now, you might repeat the same for multiple components where you have a component that deals with the shopping cart. You might have another component that deals, from if you're a system administrator, you can administrate users. You can create users, delete users, update users, or you might be, in a, in another role, and you are creating products. You are updating the prices of a whole bunch of products, right? You are doing some marketing, and so each component, each screen is dealing with different parts of a business, of the different parts of an organization, and each part of the organization is dealing with its own set of data structures that allow them to deal with that part of the business, right? And depending on who you are, you're dealing with creating courses, or you're creating the videos, right? You're creating the assignments, you're creating the quizzes, and each one has its own set of data structures, arrays and objects and whatnot, right? And each one also has its own set of functions that operate on those data structures, correct? So we want to be able to collect and organize all these various disparate pieces of the data of an organization into one single place where we can maintain the data, right? If you're storing in a database, right, where you have all these disparate data structures, you might have separate tables for the different data structures, right? You might have a table that deals with products, another table that deals with users, another table that uh, deals with orders, right, and things like that. So equivalently, that's in the database for permanent storage, right, for long-term storage. But from the user interface point of view, we also want to be able to collect all these data structures into a single place, into a single state, application state, but then be able to deal with each piece, each portion, in its own little context. And so the way Redux talks about this is they call it, each piece, each portion, they call it the slice, right? So you have the whole pie, the whole state, right, is one big pie, and then you have different slices that deal with different portions of the entire state, right? And allowing you to, have different compartments that deal with, different CRUD operations of create, read, update, delete courses, or create, read, update, delete users, create, read, update, delete assignments, quizzes, lessons, modules. Make sense? So we deal with different slices. Okay. So yeah, so let's start talking about Redux. Let's install the library, right? And let's start playing around with some of these skills of being able to integrate, right, with Redux into our own projects. Okay, so let me illustrate. So let's install Redux into our project. Let me see. Oh, change this. Okay, let's install. Let me see. Git branch 3. Git checkout 4. So let's install Redux. Oops. And let's also install a couple other things here. So yeah, so Redux is the core library that is agnostic to whoever is using the Redux, right? Whether it's a user interface, which library are you using for the user interface, whether it's Angular or Vue.js or React, right? But then you have another library which is specific to Redux, oops, right, which is React Redux. So let's install that. And then you have a very useful library, which is also part of the Redux toolkit, right, that allows us to implement all these slices and stores and whatnot. Okay, okay, so let's talk about working through some exercises, some examples, right, on and talking about the idea of creating these slices and the stores, right, and 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 moving data that would normally live in a component, and you would normally use state, right, to maintain local state, but then let's see how that would work, right, by moving it, right, into a application-wide state, right? So in the in the exercises in the book, right, we ask you to create a Redux examples component where we can put in there a lot of exercises and practice with Redux, right? The first example that we ask you to do is a very trivial, right, hello world Redux example, right, that exercises the some of the aspects, some of the simpler aspects of using Redux, right? So in our trivial example, here we have a variable that has a value of hello world, and we're just displaying that data here, right? Now, if we want this to change over time, we might use useState and initialize a state variable of message, right, with a use state of a string with a value of hello world, and then you would have mutator as well. You would have message and set message, right, if you want to be able to manipulate this, and maybe have here an input field where you can change the value of the message. Yes, yeah, but we don't want to do that. Perhaps we want to be able to share this message across multiple screens, in different components, in different places, right? We don't want it to be confined into this one single component. We want to share this message across multiple screens, okay? Again, the option would be to, put this state variable, somewhere up in the change of components and then share it through attributes. But again, we don't want to do that either. That would totally work, right? But we want to avoid that because that would create kind of like a spaghetti code, right? Where you have all these properties, kind of like drilling everywhere. So we want to avoid that. We want to move this message and put it kind of like in a global place, right? And then somehow that would be fed back into us here where we can select from this global space, global state. I want to pick out the message and then display it here, okay? So yeah, so let's move this out of the here. Let's move it into a separate file. Here it is. Right here, we're creating a slice. So we have an entire pie of multiple states that we want to put in one big state and put it in a store. And here we are implementing a reducer. The reducer is responsible for computing what the next state is based on the prior state, right? Here we are creating initializing the state of in our slice, right? And we're saying, okay, well, our initial state is that we have an object that has a property message. Again, we're trying to replicate this, right? We're trying to replicate that we had a message variable or constant with the value of hello world. So one way we can capture that is as an object of property message that has a value of hello world. And what we do here is that we use the Redux library to create a slice. Presumably there would be multiple slices, right? And then all these slices would be collected into one big store that would will be the whole state in one big storage, right? So here we're creating the slice. we give it a name, right? And we initialize it, right? We say that the initial state colon initial state, right? So this is right. This is a you know compact syntax, right, of initialize of setting a property equal to a variable of the same value, the same name, right? Initial state colon initial state plus reducers, which we don't have any. Reducers would be all the functions that would be able to manipulate the state, right? In this case, we'll take a look at that in a minute, right? All the operations that would operate on this on the state here would be here. The setters, all the setters, right, would be here, right? The equivalent of setting or manipulating or changing the state, right? We don't have any right now. Right now, we just want like a read only. I want to be able to read the data, right, and put it back into our hello world component. Yeah, so it's here the slice, and then once we have the slice, we return the reducer. Again, the reducer is the one who has all the functions and the states, right, and is able to compute what the state is, right, or the next state is. In this case, the next state is always going to be the same as the initial state because it's hard coded. Reducers are not doing anything with it. They're not modifying it. So it always stays at hello world, right? They're not modifying it, okay? So once we have this, we can collect all the reducers from the different slices. So each slice has its own set of reducers, right? All producing state. We can collect all the states from different slices, right, into one big store. The store collects all that into one big state, right? Using the configure store, right? And this is the collection of all the reducers created by all the slices. Right now, we only have one slice, right? A very trivial, really dumb slice, right? But as we progress, we're going to have a whole bunch of other slices, and we're going to put them here, comma separated, right? Here we only just have the hello reducer, which is just the import of this export over here, right? So we're importing it and we're adding it here for the reducer, okay? Once we have the store, we can import it at some top level component, right? Some parent component that is going to be the root of all the other components that want to be able to pull down the data from this store, right? So the highest level one would be the app, right? That's the highest level. But we can decide to go a little lower, right? And so I've decided to put it here in the labs, okay? And, I want to be able to separate and have the store, the data that only for the labs for playing around with multiple lab exercises, and then it'll be a different store for the Canvas application, right? For the assignment. So I decided to separate it and have, here are the store that deals only with the labs, and there'll be a different store where we do stuff for the Canvas, like assignments, courses, modules, lessons, quizzes, people, right? So that'd be a different set of slices and reducers in a different store, right? So we'll deal with that a little later, right? Here we just have some, some trivial exercises just to get a hold and practice the skills of moving state into the reducer and then being able to read it back, right? So yeah, so this is our top level component, the labs, and we wrap the entire set of labs. We wrap it with a provider and configure the store of that provider. Okay. Now, any component in our labs, anywhere in the hierarchy, right, can potentially read the data from from all the slices, for any slice, right, including lab 1, lab 2, lab 3, even if lab 4 is writing to the state, lab 1 is going to be able to read it. Actually, any component under lab 1 or any component under lab 2 is going to be able to read the data without us specifically passing any data through any attribute, right? Anybody can just select what portion of the slice to grab the state that it needs, right? So now that we have the provider, we can now revisit our hello world, our hello Redux, right? Now that message that used to live here, I can read the message from the slice, right? That was declared way out there in some other file that put that state inside of the store, that what was put inside of the root labs in the provider, and now here it is. I can extract the message, right? I can say, hey, selector, there's a reducer in the state called hello reducer. That's the name that we gave it here, right? There it is, hello reducer, right? So the state, this state object in the use selector, notice it's a function. We are passed a reference to this object, this whole object right here. This object, whatever that object is, that contains all the different initialization states, right? The current state are there. So right now, hello reducer contains this object, message hello world. And so now this object, which contains hello, a message hello world, it gets passed to us here in the use selector in the state. And the state, I can just say, well, give me the data in the hello world, hello reducer. What's in hello reducer? The object message colon hello world. And here I can destruct and extract the message property whose value is hello world. And so now I have back my hello world, right? And I can render here my hello world. Make sense? Right, so I have, way out there, a slice, right, producing the state object of message hello world, gets into the store, gets into the provider, and then back here with the use selector. Make sense? So basically what we've done is that we've separated the concerns of managing the state and rendering the state. Those are two separate concerns, right? Which is a very common, very useful principle, right, in software engineering, where we separate the concerns, right? That I want to maintain the state and all, with all the idiosyncrasies and complexities and challenges of maintaining the state, it has its own set of concerns. And then rendering, that data, that state, that's also a set of concerns. And ideally, in the principle of separation of concerns, those concerns should not live together. They should be separated, right? Each one has its own set of skills, its own set of challenges, right? And it's a good practice to separate those things, right? Here, the component should only be concerned of how do I render, how do I look pretty, right? How do I, it's a rendering engine. How do I convert this data into an equivalent user interface? But I am not burdened, right? I should not be concerned of how the state changes, how these operations modify the state. That's not my concern. That has been separated out into a reducer, right? Into a slice that's going to deal with all that. Make sense? Okay.
Hi, Professor. I have a
Yes.
question. So here we are basically using the store and Redux as a local database. Is that what we are doing right now?
Yeah, you could think of the store as a local in-memory database in the user interface. Now, it's not a database in the sense that it's long-term storage. It's not persistent, right? It's all in memory. So, for instance, if you refresh the screen, right, it all resets to its initial state, right? So you lose all the changes, right? For long-term storage, we still need the database, right? And we need a mechanism to go fetch that state, right? And then copy, right, a small portion of the state in the database, right? We would copy into here, into our slice, into our reducer, right? So that the reducer will always be a small sliver, right, of the entire data in the database, right, of whatever we are displaying on the screen. Okay, so in the database, we might have thousands of courses, right? We might have, you know, uh, you know, many thousands of students, of people. But in our reducer, we might have just a few dozen courses or a few dozen users, only what it's needed, only for displaying it on the user interface.
Okay, thank
But
you.
yes,
Got you.
you can consider it as a in-memory local storage, right? I just don't want you to think of it as a long-term storage or persistent.
Okay, got you.
Also, a big difference is that the database typically will be, um, we'll make sure that the data is normalized, right? That it separates the uh, the, the different objects into different tables, right? Trying to avoid redundancy, right? It will have references and things like that. We'll have either foreign keys and primary keys, and making sure that you have no redundancy, that everything is normalized. Whereas in the user interface, you just want to display the content, and oftentimes you will transform the very hierarchical storage data that is stored in the database, right? That is very hierarchical, has references, have foreign keys, blah 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 blah, right? And you need to select that, and typically you need to flatten, right, the data, right? And then that flattened version of the data would be what it gets displayed, right? So here we have typically the reducers is a flat representation of the data, that has been extracted from a very hierarchical representation in the database, right? Because in the user interface, you are concerned with displaying content, right? And whereas and you're not concerned with long-term storage or anything like that. So the concerns are different, right? The database wants to be long-term storage, no redundancy, blah blah blah, right? Very hierarchical, very normalized. Whereas in the user interface, typically it's not normalized, right? It's very flat, right? It's only a small sliver, and it's very ephemeral, right? It's very transient, the data that I am displaying currently. Yes? All right.
Okay, thank you, Professor.
Sure. So let's look at an, um, an example of using Redux, right, where the state changes over time, right? We just saw an example, hello world example, where the state never changes, right? The string is always hello world. Let's look at a slightly more interesting example where the state does change. So here's a sample counter where we are maintaining the state, right? And again, we saw an example of this earlier, implemented using useState, right? Where we had we use a useState, we initialize the count, and we have the count state variable, and we have a set count mutator. Yes? So here we have an equivalent implementation, but the way we're declaring the state is that we have an object that has a property count, right, with some initial value of 1, 2, 3, and we're creating a slice with an initial state where the initial state is this object, right, count 1, 2, 3. Okay. And then the manipulation or update of that state, right, would be several operations that you can do on that state, right? And those operations are implemented in the reducers. So the reducers is where you have functions that operate on the state, right? They can read the state, the current state, and then they can generate the next state. What they do is basically implement like a finite state machine, right? Where they compute the next state based on the previous state, right? Where functions are like events, right, that cause the state to change from one prior state into the next state, right? So these events of when you click on an increment button or you click on a decrement button, and they generate these events. The functions look at the prior state and they calculate the next state. So for instance, the increment might look at the prior state, which is count is 1, 2, 3. That's the current state. And they compute the next state is that the state.count is state.count plus one, right? Or decrement is that, the state.count is state.count minus one, right? So the next state is that the count either increments or decrements, right? So this is manipulating the it's traversing all the possible states that the application could be in, where all the possible values of count, right? Starting at 1 to 3. You could go up, right? Indefinitely, 1 to 3, 1 to 4, 1 to 5, 1 to 6, or go lower, 1 to 2, 1 to 1, 1 to 0, and whatnot, right? So those are all the possible states of the application could be in, of the state. And then obviously the user interface would have to render, right, all the possible values as well, right? So that, a state change reflects into a user interface change, right? So the user interface, presumably there would be a one-to-one mapping between all the possible states that the application can be in, and then the user and state, the equivalent user interface that gets rendered, right? That represents that state change, okay? And so here yeah, so these are the kind of like the edges in a finite state machine are these events, right? And then the state is, all the different possibilities where in one state the count is 1 2 3, another state is the count is 1 2 2, another state is the count is 1 3 0, all the possible state of the application, and you transition, based on you clicking, increment or decrement, and then you go between one or the other state, presumably in one, linear listing of all the possible states where you can either go right or you go left backwards. You can't just jump around, right? But certainly we could add other reducers that would allow you to set the state at any particular value, right? We could call it set count. We could, re-implement it the same way that the way we implemented it earlier, right? Where you would have maybe a set count where where you can pass in the value of the count, right? And just set the value of the count, whatever the argument we pass in, right? And that would allow you to jump between any state, right? Not necessarily in the linear +1, -1, but jump around and set the state to whatever you want, right? But that would be a different implementation. So anyway, yeah, so we are exporting the reducer, and we are also exporting the functions here, right? These actions, the functions, are being exported, which can then be imported, from anywhere that we want to be able to call these functions, right? Presumably from clicking buttons in the user interface, we want to call this increment and decrement, right? So let's take a look at that, right? So this brand new, this brand new reducer we just created, we imported into the same store that we created earlier, right? The same store that we created earlier, right? We just added to the reducer that we had earlier, the hello reducer, right? The one with message hello world. We just added at the end, right? So now this is the collection of all the different slices that we have. We have a slice that generates hello world messages. We have another slice that generates counts, right? They're all collected into this one big store, right? They're both provided at the top level labs provider. We don't have to touch that again. And then whatever component we want to read this, we can use a useSelector to extract the count from the state count reducer. See that? Count reducer. And then we can just render the count. See that? Right? Then we have the buttons. Now we want to be able to talk back to the reducer. We want to be able to call the reducer to increment and decrement, right? We want to, when we click on buttons that increment and decrement. So how would we invoke? Well, we can import the increment and decrement that were exported from the reducer, right? And we want to invoke them. Now, you would expect that we could just do, on click, and we invoke here increment and decrement, right? But that would be too easy. That would be too easy, right? It would be ideal if the syntax would have been just that, where we could just say on click, increment, on click, decrement, and be done with it. Unfortunately, it's not as trivial as that. it's only slightly more complex, but not much, almost indistinguishable. Instead, right, we use an event dispatcher. We encapsulate the event, right, and we dispatch it to the reducer, which will handle the event and will then, handle and redirect it where, who is responsible for handling it, right? This actually allows, multiple reducers being able to handle the event and not just one of them, right? So anyway, so we create an instance of the dispatch, and then the increment, the invocation of the function gets wrapped inside of the dispatch. See that? Right? So it's almost as trivial as just calling increment and just calling decrement. We just have to remember to wrap it inside a dispatch. Okay? And the dispatch gets, the instance of dispatch gets instantiated from the use dispatch hook. Okay? All right. Okay, so now, so we've seen examples where, the state is being explicitly maintained only in the reducer. I mean, we've seen examples where the state, in when we were using useState, the state was being maintained locally in the component, right, with the state variable and then the setter. And now we've seen examples where the state is being exclusively maintained in a reducer, right, in this global namespace, right? But sometimes we want to have a little bit of, right, on both sides, right? A little bit on the local component, and sometimes also a little bit in the in the reducer, right? So there's a combination of that. So let's take a look at that, where you can do both, right? We can combine maintaining one and the other. Right? So for instance, here's another trivial example where we are maintaining some kind of sum, right? And we want to, pass attributes, we want to pass values, we want to pass parameters to a reducer, right? We initialize it first to the sum equal to 0, and then we had a reducer add that we want to be able to pass parameters such as add these two values, right? Add a plus b. And so parameters that get passed into reducer functions, right, are collected, are grouped into what is called a payload, a bigger object. It's a meta object, right, that can contain all these parameters, right, in an object called payload, right, and it gets encapsulated in a bigger object that has all sorts of meta information, kind of like an event, right? When you do the onClick, right, it contains, the target and the value, right? So it's kind of like an event object, right, that has all sorts of meta information, right? The event object has things such as, the timestamp, right? Where exactly the mouse was, the XY position, it has a whole bunch of meta information that we don't care. So this is kind of like the equivalent, right? If we pass events, right, or parameters to these functions, right, they get merged into a larger object, right, which is called the action payload, right? So we're going to pass in the a plus b, and so we're going to update the sum to be the, the addition of a plus b, whatever their data type is. So we better make sure to pass these as integers, otherwise this would be the string concatenation. Careful, right? Anyway, so the reducer and the actions, where we're exporting those, we are adding it to our store, right? So we're collecting all these slices, each one responsible for the sum, for the hello world, right, for the count. And then inside of our component, we can combine some local state management, right, where we can have maybe a couple of input fields where we can type in the values that we want to add, right, a and a and b with set a and set b, where we can, type in, 1 2 3 plus 2 3 4, right? But then also notify our global space, right, our global state, our application-wide state, that hey, the sum, we can notify the rest of the application, hey, these these small little components maintaining two input fields, and I want to share with the rest of the application that the sum of these two values, is 567 or whatever, right? So yeah, so we can extract the sum. We can grab the dispatch because we want to call and pass in some values. And here are the input fields, right, where we can display that a plus b is sum, where a plus b is the local state, right, the local state variables, whereas sum, we're grabbing it from the reducer, right? So it's a combination of both, right? Some value we're keeping it local, and some other ones, or we're keeping it statewide, application statewide, right? So yeah, so we're showing a plus b equals sum, and then the input field allows us to type in the value of a, type in the value of b, and then when we click on the add button, we can send and dispatch to the function add, to state the Redux function add, and pass in an object that contains a and b, right? So this is the payload. See, it's collected as an object, a colon b, a colon a and b colon a. So we're passing the values of a and b, with parameter names a and b, with the values of a and b, right? And then on the reducer side, right, we unwrap it from the payload, and then we do the add, we update the sum, and the whole thing just re-renders with the new sum, right? So yeah, so this is an example of using both state variables and local state variables. Okay. All right, so let's take a look at a more extended example on how would you use both the use state, right, using local state variables, and then look at an alternative implementation using Redux. First, we'll implement it using a local state variable, right, use state, right, and see how this would be implemented using just plain old use state. Right? And then we'll revisit it and re-implement it using Redux. So you can contrast, how would you do one or the other, right? Obviously, if we want to be able to share this data, for instance, all these to-dos with the rest of the application, we would go with the Redux implementation. If instead, we want to keep it local and private and only within this one component, then we would go in with the use state implementation. It's your choice. It's whatever is the intention of the data that you want to share or not share, right? If you don't want to share it, typically you would go with the use state implementation. But if you want to share it across multiple components, then you would go with the Redux implementation. Okay, so let me show you. First, we'll go with the use state implementation, and then we'll look at the Redux alternative. Okay, so we have use state is an array of objects. Also, this is a little more interesting implementation where we have an array of objects now, right? So we have the to-dos is an array of two to-dos, right? Of two IDs, and then the title learn React learn node. And we also have another state variable where we have we have a single to-do. So this one is an array of to-dos, where this is a single to-do. So this will allow us to iterate and render all the to-dos, whereas this one is going to allow us to have a single input field where we can type the new to-do, click on add, right? And this new object, right, we can just append it, right, to the end of this array, right? So we have two state variables, one dealing with all the to-dos, and another one dealing with a single to-do, right? So that the single to-do can be either used for creating new to-dos or editing existing to-dos. Okay. Okay, so here we have different operations, different CRUD, create, read, update, delete operations, right? Modifying the data structure, right? So for instance, to be able to add a to-do, we can pass in an instance of the new to-do, right? Where we are, we can compute the new array of to-dos as the copy of the old to-dos plus a brand new to-do that will copy the title of the to-do state variable, this one, right? That one, whatever the title is, I'll copy it, plus, I'll compute a unique ID, right, with some timestamp, right? Once I have the new array of to-dos, right, we can set the to-dos to this new array which will include a new object at the end of the array, right? So you'll have the old to-dos plus this new to-do object at the end. And then we're going to clear out the to-do, right? We're going to clear out the title so that, so if it's an input field, and I type something and I say create, right? When I say create, I'll clear it out, right? Whatever I had typed before, right? Delete to do, I'll pass in the ID as a string, as a primary key of the to-do that I want to remove. And what I'll do is that I'll create a new array of to-dos that will skip over that particular to-do that I don't want anymore, right? So I'll pass in the ID. So I'll keep only the to-dos that have an ID that is not the ID that I want to remove. So this new to-do basically is just missing that once to do, right? We update this array of to-dos with our mutator, right? And so that will cause a re-rendering, and now that to-do will be gone, right? And then update to-do, I'll pass in, what I want to be able to do is maybe edit a to-do. Maybe I'll say that it's done. I'll change the title of the to-do, whatnot, whatever, right? And so I'll pass in that new instance of the to-do, right? Probably from this to-do that I'm editing, maybe, right? And then what I'll do is that I'll create a new array of to-dos that basically it'll be mostly the original array of to-dos, except that when I get to that particular to-do, I'll throw away the old one and I'll keep the new one, right? So this is the new one. And so what I'll do is that I'll do a map over the old array of to-dos, right? And as I am iterating and I'm looking at each to-do, I'm checking to see if the ID of that to-do that I'm iterating over, if it's equal to the to-do that I want to, that has been modified. This is the modified to-do. Maybe I changed the title, or maybe now it's done or something, right? So if the IDs match, I want to keep the new to-do, right? I want to keep the new to-do that has been modified. Otherwise, I'm just going to keep the old version, right? So if it's not the ID that I want to modify, I'm just going to keep the old version, right? Now that I have this new to-dos, right, I'm just going to set the to-dos. This will update. Again, the array will be mostly the same, except this one single to-do will have a new version, the new title or something, right? And also I'm going to clear out the input field where I was typing the updated version, okay? All right, so in the rendering of the user interface, right, we're gonna we're gonna have a list group that we're gonna have a map of the to-dos that's gonna render all the list group. But before we do that, right, above that, like our very first list group item will have an input field and a couple buttons, right? So so we have the input field, which will render the title of the state variable, right? This state variable right here, the title. We'll have learn Mongo, so it'll be learn Mongo, right? And I can edit it. I can edit it. I can set to do blah blah blah. I can change the value of the title. I can type in something blah 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 whatever, and then I can either click on add, and you'll add this new to do right to the end of the array, or um, it'll update the to do. Right now, update only makes sense if I've selected a particular to do that I want to edit. Right, so update should if the ID is -1, that would probably means that you haven't selected the to-do that you want to edit, right? Only if you click on edit, then the ID is different, right? And then you should be able to edit it, right? I didn't go as far as doing that, but it make more sense, right? So yeah, so this one allows me to edit, add, or update, and then the iteration, the loop, right? It's iterating and creating a new item for each one of the to-dos, right? And with the title there, and then the buttons where you can either delete the to-do or set to do that I want to edit, right? So notice that delete just calls delete to do and passes the ID. So that will filter out that to do from the array, right? And it'll re-render without that to do. Or this set to do allows you to, what it does is that it copies that particular to do, if you edit, it will copy it, right, in the to-do state variable, so I can edit it and then click on update. Now that will have an ID, a valid ID now, not -1. It will have the ID of the actual, to do that I clicked on to edit, so that when I do update, when I do call on the update, that ID makes sense, right? That ID does make sense. It's not -1, right? And it'll match and it'll swap it out. If it's -1, it'll won't swap it out, right? It'll ignore the update because no to do will have a -1 ID. Yep. Uh, so yeah, so that's the implementation. Now, the implementation is a little bit too big. This particular list over here, list group over here. I might, this implementation of editing and deleting. Right now, we're only displaying the title, but we could quickly, imagine that these items and this form, could grow to be much more complex and challenging. For instance, we might start adding other things in here. Maybe a checkbox saying that whether it's done or not. Maybe a drop down of the status on whether it's paused or in progress or something, right? Maybe a drop down with where we can have the date picker where when it's due, right? When we started this to do this particular task. Maybe another drop down that who is this assigned to, who's working on it, blah blah blah. Another drop down of who created this to do. I mean, this line item here could get fairly complex. Plus, this form also could be fairly complex. So, having it all implemented in one single, to-do list component might make no sense, right? It might make sense to kind of like break this out into its own component and maybe break this out into its own component, right? And so for instance, here it is. So for instance, we might break out this over here, this list group, into its own component, maybe call it to-do item, when we can pass a reference to the to-do, plus we would have to pass a reference to the event handlers, right? Because here we can call delete to do and set to do, right? And that's okay because we are all in the same file, right? The delete to do is here, the set to do is here, right? So we can just call these functions right from here. But if I break it out into a separate component, right, these delete to dos and set to do no longer are here, right? I need to pass them as dependencies, right? I need to pass an argument of reference to the functions, right? And this is what makes this implementation brittle, right? That is now there's a hard dependency between these two components because, right, the functions I'm passing and whatnot, right? Which is fine, right? If it's very self-contained, it's okay, right? Of passing these dependencies, right? So anyway, so we pass in these dependencies so that I can call delete to do and I can call set to do and I can render the to do title, right? And this would allow me to, implement something very complex, right? Add the additional drop downs, the checkboxes, the date pickers, right? And it allows me to deal with the complexity as my application grows, right? Right, as opposed to having it all in one single file, right? But this allows me to break it out, right, and deal with, the line item all by itself, the to-do item, right? So now, sorry, I would do this. Wait a minute. We'll do the same thing with the top level form, right? This one over here. We can move this out into its own component again because this could grow to be very complex as well with all sorts of date pickers and drop downs and right check boxes and whatnot. That also it's a good idea to move it out, into its own component. But obviously we need to pass in right the state variables and also the setters, right, that manipulate the data, right, because they don't live here, right? They live in our parent to-do list, which passes it to us, right? So now we can call add to do and update to do and whatnot, right? So putting those all together, now to-do list is much more manageable, right? Instead of having all these very complex implementation, we've broken it out, right, into the to-do form and then the to-do item. And then, just making sure to pass in references to all the state variables and all the setters, right, and all the mutator functions, right? We pass the references to it. Make sense? Okay. Right. How about re-implementing it, but with Redux, right? Notice that one of the problems here is that this to-do list, right, is responsible for way too much, right? It has not only the responsibility of rendering the content, it also has the responsibility of maintaining the state. See that? Maintaining the state and also implementing all the mutator functions responsible for updating the state. See that? It has too many responsibilities, right? And we're breaking a a you know a software development, a software engineering principle of separation of concern, separation of complexity, right? So a better implementation would be to separate the concerns of maintaining the state and the concern of rendering the state, okay? And that's where Redux comes in, right? We can move the state outside of the component, right? And for instance, have the data structure of the to-dos, in a state variable, and also the to-do here, right? And then also move here in the reducers all the manipulation of the state, right? Of calculating the new arrays when we add a to-do, right? And right, and resetting the title and whatnot. Also deleting the to-do would live here, and the update would live here, and the set to-do. So we've moved all that implementation from the component, we've migrated it into a separate file that nowhere here do we see any user interface code, right? There's no HTML here, right? It has no idea how this data is going to be rendered, right? And that's a good thing, right? Again, the separation of concern. This implementation has no concerns of how the data is going to be displayed, right? And the same thing in our where we're going to be rendering has no concerns of how the data is being maintained, right? So anyway, so we have the reducer. We export all the actions. We export the reducer. We add it to our store. There it is, right? And now we can go back and revisit our to-do list, our to-do form, our to-do item, right? And instead of having to pass, right, references to the mutators, right, and references to the state variables, they no longer live in our parent. Our parent can't pass us anything. Instead, all that comes from the reducer, right? We import the mutators, the functions that manipulate the state, right? We import the state variables, right? And then we notify, right? We notify our reducers dispatching these events, right? So instead of calling our functions, right, from to our parent, instead we are calling the reducer who's going to add the to-do, update to-do, right, and set the to-do, right? Same thing with the to-do item, right? We, instead of the delete to-do and the set to-do living in our parent no longer is going to have that, right? Instead, we import them from the reducer and we dispatch to the reducer, right, to either delete the to-do or set the to-do for editing, okay? And then our to-do list, now it doesn't have any of the implementation of the functions that add or delete or modify or update or to do, none of that, right? All that has migrated to the reducer, right? We only just extract from the state the list of to-dos, which we can then just iterate and pass into the to-do items, right? Notice that there's no dependency, right, between the to-do list, well, only the to-do as I'm iterating over. Yes, of course, that we can't break that dependency, but there's no state variables, there's no setter or mutator that I need to share between the parent and the children. All that is being maintained, outside, to the reducer. Okay. Okay. And we get the benefit that data of the arrays of the to-dos no longer is only available inside of the to-do list, right? Because now it's available in a global namespace, the store, and then now anybody can get a hold of that list of to-dos. Anybody can select. I can go to lab 3 or lab 2 or lab 1, any component, right? And just use a selector and say, hey, grab me the to-dos. I want to render them, right? However I want. Maybe I want to render them not in a list, or maybe I want to render them as a table, or as a pie chart, or as cards, right? Or whatever, right? And I can group them, right? Who's working on what? I can sort them in a particular, when they're due or whatever, right? So anybody has access to the data and can display it in any different ways, right? So now the data can be shared across multiple components, which it's an added benefit, added bonus. All right. All right. That's all I had for you today. Right. So we've discussed the importance of maintaining state. We've looked at two different ways, right, of maintaining state, either at a granular level at the component scope, right, and right, maintaining state at the application level, where the data might be shared across multiple screens, multiple components, right? And folks, some components can change state in one screen, and then others in another screen can be notified, right? And they can also read the state and then display it in any way they want. Okay. So please go through the lab exercises, right, for this for this section, for this module, which is this is the fourth assignment, right? That has a whole bunch of lab exercises at the beginning of the chapter in the book, right? That give you a chance to practice these skills, right? Of learning how to maintain state, different data types, and they get progressively more complex. We've seen several examples of that, right? And then you're going to take these skills of managing state in the next in the second half of the of the chapter, right, where you are asked to re-implement some of the add state management to the Canvas application, where we'll create slices, and we'll create a use state, right, to be able to add new courses, CRUD courses, be able to create courses, delete courses, update courses, add modules, and then ask you to on your own do the same thing for assignments, right? Now for the exam, right, there will be some questions of using the use state, right, but no questions on Redux. Right? So you can expect using use states to declare state variables, and also using setters to append to arrays, to manipulate objects, right, or simple data structures, or simple primitive data types, but no Redux, right? So no Redux. So definitely, navigation, and encoding data in in the path, right, and also use state to able to manipulate, create forms and manipulate data structures and data and whatnot. Okay. Anyway, that's all I had for you. Let's have a short break, and when we come back, we'll do office hours. Right. Again, if you need help with your assignment, or have questions with your project, or if you have any personal issue, we can jump on a room and in Zoom, and we have a private conversation. So yeah, let's take a quick break. When we come back, we'll have office hours. All right. All right. Be right back. And good night.